Well, now we're going to get into a bit more about coral reefs in a little bit more detail. That's an ordinary coral, very common coral you'll see any time you go for a snorkel on most coral reefs of the Indo-Pacific. And in the top right-hand corner there, you'll see tiny little algae. They're microscopic. You need a fairly powerful microscope to see them. And these little algae, well, they live in the ocean, free in the ocean, but they invade the coral tissues, and they are responsible for harnessing sunlight to generate sugars to power coral growth. Now, what has happened with temperature? These algae love to be warmed up because the warmer they get, the more photosynthesis takes place, the more sugars they produce, but the more oxygen they produce. And so, as temperature warms up, they produce levels of oxygen which become toxic. Now, almost anything will die if exposed for long enough to high levels of carbon dioxide. We will, corals do also. And they have two choices. One, keep the zooxanthellae, these algae, in their tissues and die, or two, get rid of the zooxanthellae. Well, they try to get rid of them, and they find they can't live without the zooxanthellae. And they turn white and die. They turn white because the color of a coral is due to the algae, not the actual coral itself. Well, that's an ordinary common or garden coral reef that, if you're lucky and it hasn't been trashed by something, that you'll see today. And the thing to notice about that, and why I've got it here, is that you'll see all those corals are full of fish life. Now, if you're a big fish and you want your dinner, you'll go and chase a little fish, and the little fish will dive straight into the coral protection because those corals are tough and they afford protection for those little fish. But they also afford protection for around about 25% of all the species of the ocean. Now, that hasn't been calculated accurately, and I've been pondering that one, and I think it is probably more like 50% of all the species of the ocean live in coral reefs. So they're rather like the rainforests of the sea, but only much, much more so. They contain a giant proportion of the entire biodiversity of the oceans, which is why during mass extinctions, when coral reefs fail because of changes in the chemistry of the ocean, everything else goes extinct with them. So much marine life depends on coral reefs. Now, this is what happens when corals bleach. I've just come back from a diving trip in Papua New Guinea, and I'd say about half the corals I saw there were bleaching from this last summer they had. They weren't supposed to because it wasn't an El Nino year, as you probably know, but a lot of them were bleaching, not completely, so most of them will probably grow back. But when they turn really white, they have lost all the algae in the tissues, and every coral you will see in this photograph will die. And eventually, the coral will break down and form rubble, and that's what a typical badly bleached reef looks like after a couple of years. But as time goes on, and if the water's healthy, it's like it is on most of the Great Barrier Reef, for example, new colonies will grow. And they'll grow quickly, and coral reefs are very good at restoring themselves. And so we can have this beautiful looking chocolate box type environment turned over to a piece of rubble and then back again in cycles. And one of these cycles can take as little as 10 years to take place if you have a really, really good environment, if there's no pollution in the water, if there's nothing that will set the corals back. Now that's a photograph I took, I hate to say when, but I've been diving on the Great Barrier Reef for 45 years. And I think about that coral, that photograph's about 40 years old, maybe 35 years old, because when I first went to this reef, Britomart Reef near Townsville, it had been absolutely trashed by the crown of thorn starfish, and there was almost no coral left. And I went back there, and it looked like that. Most reefs look like that normally then. And so I'd use a camera for my work, but if there's a bit of film left in the camera, I just click a few shots and I got pictures like that every time. Everywhere you looked, coral reefs look like that. And then this particular reef was absolutely completely trashed by bleaching, and there was barely a coral left. And I'm happy to say it's all grown back again. So in my lifetime, I've seen 2 of these cycles completely. So if a reef's growing in a healthy environment, it can recover. If it's not growing in a healthy environment, recovery is a lot slower. But whatever the case is, this bleaching is really a horrible sight. It's initially very spectacular because everything's now white and it looks amazing. But then it starts to look really horrible. And these are just pile of photographs of bleaching. You see that little anemone fish, he's living in an anemone. It's not only corals that bleach, it's anything that will needs algae to grow. Now, needing algae to grow is then the cause of the success of coral reefs, but it's also now the danger for all coral reefs. And so this algae, unfortunately for it, was depending on, the anemone was depending on the algae in its tissues, and it's bleached, it will die. This bleaching also affected some big, solid, massive corals that grow as high as, just about as high as this auditorium, which can be 600 or more years old. And in some places in the Great Barrier Reef, masses of these ancient corals died all in the 1 year, and they all turn white and they all look like that. And the following year they all look grey-green because they're covered with algae. So looking back helps us to look forward. Now, looking back, there's one thing that's very, very important to take into account with the oceans. If you get a saucepan of water and put it on the stove, that saucepan of water doesn't immediately boil. It slowly warms up and then it gets to a boiling point if you've got the gas up enough. But that takes some time because there's a lag time due to the thermal inertia of the saucepan and the water that's in it. Well, the ocean's very big and the lag time is very great. And so it's at least 20 years before the oceans even look like equilibrating with the environment of the day. So we can take a look at what the conditions were which led to all this bleaching. When we had 320 parts per million of carbon dioxide, everyone I think in this audience was alive, but some were awfully young. It was a long time ago, and 320 parts per million was a safe time for coral reefs all over the world. They were not being affected by the increase in carbon dioxide which was taking place. But when we reached 350 parts per million, we saw the first bleaching on the coral, on the Great Barrier Reef, and then in so many other parts of the world, especially the Caribbean. When we reach 390 parts per million, and that's what we have today, we will see compounding long-term effects on all coral reefs. So that at this level, the reefs will bleach, then they'll recover, then they'll bleach again, and they'll recover. But this recovery time will get shorter and shorter as the amount of carbon dioxide increases and the return time, if you like, gets less and less. When we reach 400 parts per million, which is very, very soon, it's got there in that second dot there. I made this slide a little while ago. We will see major weather events happening. Now, that's a gross understatement, really. And I think I might show you. The frequency now of severe weather events all over the earth is increasing at a very, very rapid rate. We've seen bushfires in Australia, floods. We've seen a huge increase in cyclones. The first level 5 cyclones in Queensland, 5 of them in the last 5 years, 1 in the preceding 30 years. And this will, of course, increase because the amount of energy that's on the Earth's surface is causing these weather events. And they will pick up and pick up and pick up. It will cause severe bleaching, mainly during El Nino years. Now, El Nino is the southern oscillation which occurs every 4 to 7 years, that occurs across the Pacific. Now, El Nino has got nothing to do with climate change. It's been around for millions of years. But what it does do is enhance any warming effect there might be. It causes natural floods and droughts. It has for as long as it's known. But it will accelerate them. It will increase them. And so we look to El Nino years for the times when we get these big cycles of bleaching. Now, what's happening is, it's already started to happen, is that bleaching now is jumping the gun. It's also happening in non-El Nino years. And we know that this year was not an El Nino year, it was the very opposite, La Nina year. Yet, when I was up in Milne Bay in Papua New Guinea, I say, huge proportion of the corals had bleached, and that wasn't even an El Nino year. And so what we're moving towards now, we've already moved it, are conditions where severe bleaching is liable to occur in most years. Perhaps not some, because if there's a lot of rain, it will stop bleaching. The rain will cool the ocean surface, and clouds will protect the reefs to some extent. But it will occur in most years. In other words, we'll leapfrog the El Nino cycles. Now, when this happens, the recovery time, the 10-year return time that we need for reefs to recover won't be there. They will be bleached more and more frequently. When we reach, if we reach 500 parts per million of carbon dioxide, we will have a global temperature increase of coming up to 3 degrees. That won't happen immediately, but as the Earth as our atmosphere comes into equilibrium with the oceans, it will reach about 3 degrees with 500 parts per million carbon dioxide. Now, it's important to realize in all this that the oceans are in charge, not the land. We think about temperature as temperature we feel or what's recorded on the news, but actually the oceans are completely in charge, and the atmosphere is just a puppet that responds to the temperature of the ocean. The only thing that really matters, ultimately, is the temperature of the ocean, because that's where all the mobile heat is, that's where the heat is absorbed. And as I say, 500 parts per million will cause bleaching every year. Well, 550 parts per million, we're still looking at a time when there's loads of young people today will still be pretty young, and that will cause a temperature increase between 2.8 and 5.8 degrees. This can be predicted with quite a high degree of accuracy now. Now, you may think, well, that's not a big temperature increase, we can do with that. But just look back at the temperature of the average temperature of the surface of the Earth during the ice ages. It went down to 6 degrees below present. And now we're talking about almost 6 degrees above present. When it was 6 degrees below present, all of Canada and most of, say, the northern United States of America was under 2, 3, in places 4 kilometers of ice. All Europe was under ice. England was all under ice, with a decrease of 6 degrees. We're talking about an increase of almost that amount. So, we are obviously going to cause a huge increase in sea level. Sea level increases when you melt ice that's on land. It's not affected by ice in the ocean as in the Arctic Circle. If that melts, it doesn't affect sea level because it's like an ice cube in a glass of water. It melts, but it won't change the level of the water in the glass. If it's on land, it will. So if we get 550 parts per million, and we are not looking far into the future for that, we are setting in place the conditions which will melt all the ice on the face of the Earth except for Antarctica. And as you probably know, the West Antarctic ice shelf is a wild card in all this because the West Antarctic ice shelf has melted as a result of carbon dioxide. So we've briefly, and these slides are out of date, but the successive slides have not been produced yet. We've had the predictions of the Intergovernmental Panel of Climate Change, and that's the organization that has done most of the predicting. They've got it wrong as far as carbon dioxide is concerned. We're tracking well above now, and we're up to about there now, all the predictions of the IPCC. With temperature, we're tracking right at their worst prediction. When sea level, well, we're going way above whatever they predicted. And there's so many wild cards in that. Many think that the sea level could be up as much as 2 meters this century, and some more. And so I won't go on about sea level because that's a human thing. Sea level's not going to affect coral reefs too much, but it sure will affect sea levels. Now, ocean acidification, I think, is the most dangerous thing of all. Ocean acidification is simply the dissolving of carbon dioxide in the ocean surface to produce carbonic acid, which turns carbonates into bicarbonates. Simple thing, yes. Very simple chemistry, been known for 100 years, and that will stop corals calcifying. It will stop anything calcifying that's living on the ocean surface. And very briefly, I think I need to be very brief, if you look at the pale blue there, it means that animals can calcify very happily. If you look at red, they can't. So when we had 280 parts per million, the chemistry of the high latitudes, the Southern Ocean, for example, even if you warmed it up, you couldn't grow a coral reef in it because of chemistry. That chemistry will change progressively as those years change. 450 parts per million, we're seeing all or almost all coral reef regions being under stress. 500 parts per million, that yellow is really coming in, and at 550 parts per million, there's virtually nowhere on this planet that corals or anything that produces carbonate skeletons can grow. And at 650 parts per million, we're still well within the century. Nothing can produce carbonate skeletons. There are these graphs, they're computer predictions, and there's a lot more detail and ifs and buts and maybes to add, but still, that is the broad picture. And to my mind, it is a really horrifying one because it harkens back, obviously, to the cause of mass extinctions. And I think science can't show it, but I think there is a really good chance that we are embarking, we will set loose the conditions that will plunge this Earth into the 6th great mass extinction. Okay, what does an acidified coral reef look like? That's what an acidified coral reef looks like, and believe me, there's nothing living in this stuff. It really is dead, and that's it. There's plenty of acidified reefs now. That's another one, and there's nothing in it. Occasionally a coral will grow, and that's a disease there, that band there. That disease will kill the coral, and that'll be the end of it. So this is, as I said, very, very cheerful talk. I've given it a very, very quick run through. There's all ifs and buts and maybes, but I must emphasize that everything I've said, except my belief that we are in danger of initiating the 6th world mass extinction because of ocean acidification. That's a personal point of view. I can't prove it, nobody can. So science maybe has very little to say about it, but the rest is just plain science. It is not fiction, it's not cherry picking, it's not balancing anything, it is reality. So when you've got that reality, we have got an enormous case for doing something as a matter of extreme urgency about carbon dioxide emissions. Carbon dioxide is a rare gas. There's less carbon dioxide in the atmosphere than there is argon. It's a rare gas, and so it's not easily extracted from the ocean, from the atmosphere. So we've got to stop putting it into the atmosphere. That is the only way of stopping this very clearly predicted chain of consequences. It's not just for coral reefs. It is for all life on this planet. Humans are not going to survive the next mass extinction in any form that we know. Maybe some can in a space wars type techo environment, but who'd want to live through that? Thank you very much. I gave that story to this little fellow once, and he had to talk about it. It's an eel, and he doesn't know anything about all this. And so I feel that we've got to speak up for him and all the other life in the ocean, because they're victims of our doing and we're responsible for them. Thanks very much.
Thank you, Charlie. And I'm sure you found that as fascinating as I did, if not a little horrifying as well. I didn't realise, among all the other things I learnt today, that coral was such a wonderful barometer of what we've been through and what we perhaps will go through. But what I'd like to ask you is, when you talked about how the reefs are being bleached and then they get less and less amount of time to recover, how long do you think it will be before we actually see a reef such as the Great Barrier Reef and the size of the Great Barrier Reef effectively die?
Well, we've already seen now, excuse me, several reefs which have been, all the corals have been wiped out through bleaching. In fact, there's a lot of them. And some of the photographs I've shown are of those reefs. Now, if that can happen to one reef, it can happen to the whole lot. In other words, we could have one, if next year is a really good El Nino year, good inverted commas, it could wipe out all the reefs all in one go.
That's frightening.
It is frightening as that. This could happen within the space of a couple of years.
And I should say, if anyone has questions for Charlie, please raise your hands.
This is absolutely possible. I mean, it's well and truly on the cards. Some things come to the rescue of some reefs. Now, and I don't know if I said this, to have a bleaching, bleaching must be caused by temperature increase as well as light. The light's got to be there. In fact, if you cover a reef with shade cloth, it won't bleach. So it's a combination of light and temperature. But there is nothing in today's world now that would stop the Great Barrier Reef from being wiped out in a single bad year.
In a single year?
In a single year.
Does anyone have any questions for Charlie? And we'll bring a microphone to you so that he can hear you clearly. Charlie, would you like to sit down, or are you happy to stand where you are?
I'm happy to stand.
Okay.
So I'll pace back and forth.
Go ahead.
Charlie, it seems the only way it seems the only way we can have a conversation about this is through an economic lens. We talk about this as $6 billion worth of lost revenue for the nation in terms of the Great Barrier Reef, and I'm very interested in your thoughts on how we transform the conversation so that we actually talk about biophysical reality rather than just economic nonsense.
Yes. Yes, and things, well, I almost would want you on the stage to answer that, but anyhow, yeah, it's somehow, just somehow, we have got to, well, let's step back from that. Somehow we've got to get decision makers to actually understand what's happening. And I'm a scientist, I'm not a politician, but I did have Malcolm Turnbull with me for an hour, and he did grasp this whole lot. Now, I think if I had Tony Abbott with me for an hour, I don't think I would get anywhere. I won't get into politics because that's certainly not my field. What we somehow must do is to make our political leaders aware of the immediacy of the whole thing. It all seems like, and it's treated as if it's something that's really out there in the distance. Greenies complain all the time. Well, greenies always complain. And so you get sick of greenies complaining. But this is not about greenies complaining. This is about science. And we have to have things that we talked about. We have to be able to put this in, as you say, a biophysical reality. The Earth is changing, and we are going to be forced to change with it. We're going to have to be able to live in a very different environment. And this is not just to do with coral reefs. The reason that coral reefs lead the way is they're all about carbonate. Coral reefs are carbonate platforms. Everything about them is carbonate. That's why they're so closely linked to carbon dioxide. But that only means that they're the first cab off the rank. All the other cabs are stacked behind. And so where a mass extinction always has a domino effect. And that domino effect will kick in. Now, it'll kick in easily. And I don't want to make this audience any more miserable, but there is a point where the amount of carbon dioxide that humans are releasing will become irrelevant, because we will warm the Earth to the point where the tundra will melt, and this is happening. The melting of the tundra will contribute as much carbon dioxide as humans, and tundra is melting. The Arctic has huge amounts of methane under it, and the Arctic, as you know, is starting to become free of ice in summer. That methane is being released. The oil drilling areas, such as we've seen in the Gulf of Mexico, that potentially can, again, release as much methane as the tundra. Now, these releases of methane is about 22 times as potent as carbon dioxide as greenhouse gas. Now, when this starts being released, no matter what humans do, it will snowball. And it will keep snowballing until all the methane's on the surface of the Earth has been released. And we will have a temperature that is uninhabitable. The Earth will be plunged into a mass extinction. Now, how we get that message across is the big, big challenge of this century. Well, this decade, in fact, this year. And good on you. I mean, we've got it. That's why I'm here. I feel like an albatross around the neck of the ancient mariner.
Another question? This gentleman in the centre here.
Charlie, as a scientist, what do you think the true apolitical parts per million goal should be? You mentioned that we're presently at 390 parts per million, and you mentioned before when things were more stable, we used to be at 320 parts per million. Do you think we should be aiming for a target of going back to 320 parts per million to have stability?
Absolutely.
And if so, okay, what kind of lag time? I mean, say for example, if overnight we suddenly magically went to, renewable energy, what would the lag time be in going back to 320?
Well, if we switched off carbon dioxide emissions today, the carbon dioxide's got a resident time of about half a century, so it'll be a slow process. Everything is slow when it comes to carbon dioxide, so it gradually tapers off. The issue in all this, the central issue to do with the political level, to do with Copenhagen, is that Copenhagen was all about, I think this is relevant to your question, Copenhagen was all about the science of climate change. It was all about the economic impacts. It is all about the impacts on humanity and what humanity can do about it. Hardly a mention was given to the ecological impacts of our natural ecosystems. And so when I gave a talk similar to this at the Hadley Centre, they said, but you can't say that because we're going for 450 parts per million at Copenhagen, and now you're saying that'll kill everything. Well, I say, well, I can't say that because coral reefs uniquely on this earth are telling us just that. So we've got to get the target right, and although that target does seem increasingly difficult to get, we must go for it. And I could say 20 years ago that target would have been pretty easy. Now it's not easy. There'll be a lot of pain. And 20 years' time, it won't be possible. I think.
One more, couple more questions. Like, with that high level, what's the extra margin? I mean, because we're talking about, even if it was, 390 parts per million of CO2, as you say, you've got melting tundra and you've got all that extra methane gas going up. So what's the true equivalent then? It's even higher than isn't it?
Yes, we've already passed the 450 parts per million carbon dioxide relative. In other words, if you add all the greenhouse gases together, it's got a warming effect now greater than 450 parts per million. So all the information I've shown you excludes all the other gases and all the other, it excludes methane and nitrous oxide and all the rest of it. So the actual real position is actually worse than that. But I stuck to carbon dioxide because I want to make things relative, carbon dioxide being the thing that's preserved in ice cores and so on. Yep. But it will remain the biggest component, but methane will, as the century progresses, start to catch up and be one of the big ones as well.
I have a question for you, Charlie, before I go to somebody else quickly. I know you said you're not a politician, but how do you take the politics out of an argument like this so that people actually start to take notice of the science, in your opinion?
I think it is very important to say a politician wants to stop a carbon tax or emissions trading scheme or whatever, to not talk about all the problems, all the costs of that scheme to today, to talk about what it means to our children. Because then the argument takes on a whole new meaning, which is absolutely realistic. And so I'm afraid if I was a politician advocating action against climate change, I would be talking about our children, not just about the cost to the hip pocket of today's people. There will be a cost, but if we don't start paying it, that cost is going to go up exponentially. Yeah. But it will be catastrophic for our children. And so I get really in tears just about, actually, when I hear some of the things that are on television now, and I think of my own children and what it will mean to them. It will mean that they will not have anything remotely like the life that I've had.
What sort of life will they have?
Well, they'll have wars everywhere. The earth will be plunged into wars everywhere. I could give you a run around the world of what it would be like by mid-century. In fact, I went to a very, very good talk in this room at the Brisbane Writers' Festival, and about just that, about the climate change wars. And it's real. And basically, the whole of North Africa will starve. Mexico will starve, want to move into the USA. Pakistan will run out of water. Pakistan will fight India because all of Pakistan's water, the Indus River and a few of the others, have to cross India. There's a treaty, but is India going to go without water and still let it through into Pakistan? I don't think so. And so on and on and on. We have to, yeah. And right now, the Australian Department of Defence thought that climate change was not relevant to them. The American Department of Defence, whatever it's called, said that is their biggest concern. Now Australia's catching up. They're finding it is going to be Australia's biggest concern because the world is going to be very, very different and changing very rapidly. The issue is the immediacy of the whole thing. It seems strange that we've had all these terrible bushfires, all these awful floods, and people are still not thinking. They're still saying it's once in a century or once in a lifetime. It's not. It's once this decade, and soon it'll be this year.
You did promise us it wouldn't be a happy talk, but anyway. Any other questions for Charlie? This gentleman here in the front.
Charlie, I just finished reading Oresky's and Conway's book, The Merchants of Doubt. You're asking about what scientists can do in terms of communicating information to the general public. We've got a couple of problems. First of all, we've had dumbing down of the general public because science, etc., not being taught in high schools, or fewer students going and doing science and going on to university. And then the other thing is that a couple of scientists actually hijacked the process, and they were getting their information into the mass media, whereas the scientists, they would challenge those assertions in the scientific literature where the scientists read it, but the general public doesn't read it. Okay, so we have to change our approach. Any ideas as to what avenues we could use to get this message across, given that we don't necessarily have a scientific literate public to talk to?
I absolutely agree with this, and basically science has fulfilled its role in this whole thing. Science will keep on filling in details, keep on updating it, but the job now, the baton has been handed to communicators to communicate the science to the general public. And I can tell you now, I don't like giving these talks. They're miserable. And when I'm out of here, I'll be talking about this subject. Tomorrow I'll be talking about this subject. I'll be talking about this subject almost every day of my life. And I hate it. I used to be good fun diver who just loved playing. And I've had to give that up because I just see what's coming, and I've got to do my little bit to try to put on the hat of a communicator. Now, I wrote a book called A Reef in Time, The Great Barrier Reef from Beginning to End. And I wrote that for the general public. And its review says it gets technical here and there. It gets difficult to read because it's called a technical book. It's not. It's a general public book. But it's very difficult for a scientist to assess what a non-scientist knows and doesn't know. And that's not speaking any sense of arrogance on the part of a scientist. We've forgotten that what it's like not to be a scientist. And that's true. So what we need are people who understand the science and are good communicators. And what we need most of all is the media who will stop this ridiculous farce of having to produce a balance between climate change advocates and denialists, because it's absolutely tens of thousands to one. We've got two geologists, one of whom I've known all our respective lives, and I know exactly what his problems are. I know exactly why he's come out the way he has. And it's all personal stuff. We've got to have a media who puts things in some sort of balance, a good balance. And the easiest way of doing that, the most fairest way of doing that, is to just restrict our media coverage or our statements to the process of peer-reviewed scientific literature. Now, the book I wrote was published by Harvard University, and the rats took 1.5 years to publish that book because it was being reviewed by everybody under the sun, and I had to answer just hundreds of reviewers. It helped me. It was a wonderful process. It was great. But the two books that have come out in a similar vein, they've been written and published in 6 months, and out they come, and they get advertised absolutely everywhere. You've never heard of my book. You've heard of both those other ones for sure, because they get advertised everywhere. It's like if you walk down a street with your clothes on, no one will take attention to you. But get your clothes off, and you'll be surrounded by, well, police, I suppose, but the media wanting to know why you did this. So I sometimes feel like stripping off. And it wouldn't be a nice sight.
With climate change, though, with global warming, we'd be able to walk down the street without our clothes and be okay, wouldn't we?
That's right. We need to be warmer. Yes.
I think we're supposed to wrap up at 2, so we've gone over time, and I think perhaps the question from the last gentleman for me nailed it on the head when you said it's difficult to assess what non-scientists know. I'm a non-scientist, and I think if the general public were to come to more talks like this, it would communicate to us a lot better what the politicians simply cannot. So please join me in thanking Dr. Charlie Burns.
Thank you for coming.